grade 10. How are you today?
Good morning. We're fine, thank you.
What about you? I'm fine too. Okay, let's
This
start.
is stopped at vertical asymptotes, yeah?
Yeah. Now, in the previous lesson, we talked about how can we find the points of discontinuity, the x-intercept and the y-intercept. Now, today, we will talk about now how can we graph the functions. How can I graph the functions? By finding the vertical asymptotes, the horizontal asymptotes, the x and the y intercept. The question is, how can we find the vertical and the horizontal asymptotes? Now, we said that the rational function f of x, it was q of p of x over q of x. I want now to know how can we find the vertical asymptotes. If I want now to find the vertical asymptotes, I just here to check the zeros of the function. So the vertical, I have to look at the zeros of the function. If the zeros now are common zeros, what I have to do, and if they are now non-common zeros, what I have to do. Common zeros, I mean that there's a common zeros between the p of x and q of x, between the numerator and the denominator. So let's
So what do you mean about common zeros?
What do you mean about what?
Common zeros.
Wait a minute, I will explain for you. Now, let's see the zero. When I see that, like f of x or y as an example, it will be x minus 1 over x minus 2. Now, for this function here, what is the zeros? What is the zeros of the numerator when x equal 1? And what is the zeros of the denominator when x equal 2? Now, let's see, is the zeros or are the zeros of the numerator and the denominator are the same? No. So I will go now to the non-common zeros. There are non-common zeros between them. This type of this function, when there's no common zeros between p of x and q of x, I will say that the vertical asymptotes, will be at x equal to. So from here now, when we have no common zeros, okay, so the vertical asymptotes here, it will be at each real zero of q of x. If there's no common zeros, as we said here, so that means that I will check now the zeros or real zeros of the denominator or of q of x. This if we have now a non-common zeros.
So if you have non-common zeros, you will choose the denominator?
Yes, we will use the zeros of the denominator or of the qx. Now, what about now if we have a common zeros? Like as an example, x minus 2 over x minus 2 plus times x plus 3 as an example, as like this function here. For this one here, did we have a common zeros? Yes, this one and this one, they are common. So if we have now a common zeros, I will see that, I will say that here, that we have at point x equal negative 3, we have now our vertical asymptotes. So I will repeat now that before the step, I can say now, sorry, for the non-common zeros, I will check if they are, I will check the real zeros of the denominator. If we have common zeros now, I have to check two things, the power of m and n. And by now, we have two things. M, it could be greater than n, and m, it could be less than n. Now, if m is greater than n, what is that? What do I mean if I say m and n? Like, if the power of m, and here is n, if the power of m is greater than the power of n, so I will say that there's no vertical asymptotes. But if n is less than n, as you see here, I will check that here. If there are a common zeros, yes, there are this one and this one. So because of that, I will say that at x equal -3, my vertical asymptotes. Let's see now an example.
Teacher, what do you mean by if m is greater than n, then I will not have a vertical asymptote?
Like here, the power of the example squared plus 2x minus 3 over x minus 2. Like this one here. Okay?
But
Here.
it does have a vertical asymptote.
What?
But it has vertical asymptotes.
Did I make a...
Teacher, isn't that only in horizontal asymptotes?
Yeah, I thought that too.
Yeah, come on. Please, no, no, come on. Okay. For this one here, so may I have now to retype my classification. Now see, if m is greater than n, I will check two things here. That sometimes we have some difference. Look here. If m is greater than n, like the
Can you explain what you mean about like m greater than n? Like, do you mean that
Oh,
x equals 2?
No. I told you on Wednesday. M is the power of the numerator, and n is the power of the denominator. Like here, m is 1, and here we have x times x squared. So n here is 2. Here now, m is less than n. So I will use this one. Now for m is greater than n, I will go back now and will check the zeros. If we have common and non-common. Like the previous one, it was x squared minus 2x plus 1 as an example over x minus 3. Look at this one here. Here now we have x minus 1 times x minus 1 over x minus 3. Now, in this one here, the power of m is greater than the power of n. The second step, I will ask myself, did we have a common zeros? No common zeros, so I will use x equal 3. But if there is a common zeros, like make this one, it will be like x minus 1 like x minus 1 times x minus 1, x minus 3 over x minus 3. By now here, what about the degree of m? It is 2. And here it is 1. 2, it's greater than 1. So I will ask myself, is there a common zeros? Yes. If there's a common zeros here, I will say that there's no vertical asymptotes. But there's no vertical asymptotes, but there's a point of discontinuity, which is at point x equal 3. Is it clear now?
I get confused.
No? Okay. If now I want to find the vertical asymptotes. What's the meaning of the vertical asymptotes? Like this. This one we call it vertical asymptotes. Vertical asymptotes is mean at x equals something. Now, for the vertical asymptotes, I have to check now what? I have to check the if I have to repeat it as n equal n or n. Okay, I have to check now the zeros of the function. Now, if we have a common zeros and if we have none, and if we have none common zeros. Now, if we have, let's start now with the common zeros. Now, for the common zeros, m, it could be greater than n, and m, it could be less than n. And for the non-common zeros, also m, it could be greater than n, and m, it could be less than n. I will repeat, what is m and what is n? M and n, I mean hereby the power of p of x and n for the power of q of x. This is m and this is n. Now, if we have now x minus 1 over x minus 2 over x minus 2 here. Okay? For this one here, m is greater than n. Why? Look at the power of the numerator. It is 2. X times x is x squared. So it's 2. And the power now of the numerator, it is 1. So is there a common zeros? Yes. So I will say now here that because for this one, there's no vertical asymptotes. But there's a point of discontinuity, not vertical asymptotes, not a line. It's only a point at x equal to.
You said
So
this one
here,
is common zeros, yeah?
yes. No, this is. I'm sorry. I make. Okay, sorry. This one for common zeros. Here for non-common. So for a common zeros, they were simplified. So I will say for this one here that there is no vertical asymptotes, but there's a point of discontinuity at x equal to. So when I want now to graph this sketch, I will say at point 1, at point 2, sorry, here, 2, like, and I find its value. As an example, it was here. I will say the graph, as an example, it will be like this. So there's no vertical asymptotes. The vertical asymptotes, it's mean I have to do it like this. here only there's a point of discontinuity, which is at x equal 2. Now, what about now n is less than n? As an example, x minus 2 over x minus 1 times x minus 2. Is there a common zeros here? Yes. They are x minus 2. So I will say now here that the vertical asymptotes is at when x is equal to 1. Now, for now, the non-common zeros, like x squared minus 1 over x plus 2.
Teacher,
Yes.
in point of discontinuity, this one and the common zeros, why it is not x equal 1?
No, here I said about the points of discontinuity at the zeros of the numerator. In problem number 1. Now, for the non-common zeros, if you have now m is less than n, like x squared minus 1 over x plus 2, it will be x minus 1 over x plus 2 over x plus 1, sorry, over x plus 2 here now. By now here, did we have a common zeros? No. So if there's no common zeros, I will look at the zeros or the real zeros of q of x, which is at x equal negative 2. So the vertical asymptotes here when x equal negative 2. And for m is greater than 2, or for m is greater than 2. Sorry, because here we have 2 and 1, so m is greater than n. But when m is less than n, like Maya? Maya?
Yes, teacher.
Why are you coming late?
Sorry, teacher, but my network wasn't fixed, so I fixed it and I came. I'm sorry.
Okay. Now, for m now is less than n, like x plus 2 over x squared minus 1. Here also, I will check out the zeros of the function. Now, is it clear?
Teacher,
Yes.
can you explain the non-common zero again?
Again, for the non-common zeros. Non-common zeros. It means that there's no zeros to simplify, no zeros to cancel. So just look at the zeros. Here. Look at the real zero of q of x. Just that. Is it clear now?
Yes, yes.
Okay. Now, finding the vertical asymptotes. In this problem now, we have to find the vertical asymptotes of y equal x plus 1 over x minus 2 times x minus 3. So, what about the zeros here? They are common? Are they common? Or are they common?
No.
Sorry.
No.
No, so they are not our non-common zeros. So they are non-common zeros, so I will look at now the real zero of the denominator. So I will say that the vertical asymptotes at x equal 2 and x equal 3. How? It means that I will look at the zeros of the denominator. So x minus 2 times x minus 3 equal to 0. And as we said before, one of them, it will be 0. X minus 2 equals 0, and x minus 3, it will be 0. So at x equal 2 and at x equal 3. Let's go now here. Y equal x minus 2 over x minus 1 times x plus 3. The same, I will ask me the same here. Did we have here a common zeros?
Non-common.
Non-common.
Common zeros. Then what I have to do now?
M is less than n.
X equals x minus 1 equals 0 and x plus 3 equals 0. So the vertical asymptotes are x equals 1 and x equals -3.
Teacher, first we should see the m if it's greater than n or no. Yeah?
Can you repeat?
Let's see the first if it's m greater than n or less than n.
Yes. Here it is less than n is less than n. So there's no problem. I will check now the common zeros. Is there a common zeros? No. So the vertical asymptotes at x equal 1 and x equal -3. Let's do now C. And see here we have x squared minus 1 over x plus 1. I will now factor the numerator. It will be
Plus 1 times x minus 1.
over x plus 1. Did we have a common zero?
Yeah.
Yeah, we have a common zeros. For now here, what
No
is the
vertical. No vertical asymptote.
Yes, thank you. Now for the common zeros, so every time for the non-common zeros, every time we have a vertical asymptotes. But for the common zeros, I have to check m if it's greater than n or m if it is less than n. If m is greater than n, as you see here, what is the power of the numerator? It is 2. And what is the power of the numerator? It is 1. So there's no vertical asymptotes. But if m is less than n, yes, we have a vertical asymptotes. So back here, m is greater than m. As you see here, here we say that the function, it will be x minus 1. And I will draw it now as a linear function, but at point x equal -1, we have a discontinue. Oh, sorry, I will name it as a point of discontinuity.
Okay.
Here, as an example, here, I will draw it like this. Yes? Who says, teacher?
Yeah, teacher, I have a question.
Yes.
Page 515, the third paragraph. Okay, the point of discontinuity, it is negative plus 2, yeah? But why they stopped at in the vertical, like in the y-axis in 1? How did they found the point of the y-axis? That is 1.
Yes.
Like the point of discontinuity is 2. But how they found the one?
Rose, wait. There's some disturbance. Please not unmute on the microphone. Yes, Rose.
Teacher, page 515 in the third paragraph, the point, the asymptote, it is plus 2, yeah?
And the previous one, yes.
Yeah, it is plus 2. But how they found that in the y-axis they will stop at 1?
You mean this one here?
Yeah, the third paragraph in page 515.
Actually, I don't understand you.
Page
How can you
5, like teacher page 515 in the third paragraph that it is y equal x plus 4 over x minus 2. The the asymptote in the x-axis it's plus 2, yeah?
when it was x squared minus 4 over x minus 2?
Teacher, y equal x plus 4 over x minus 2.
Okay.
Yeah, and plus 2 it is the asymptote, the x asymptote. But how do you
The
find the y asymptote?
this, you mean the horizontal asymptotes?
Yeah.
Wait, Rose. Later on. Just to know how to find the vertical asymptotes.
Yeah, okay.
Okay, now let's now find the horizontal asymptotes.
تيتشر
For the yes,
تيتشر لما بتقولك الداخلية
okay. Now let's see how can we find now the horizontal asymptotes of a rational function. To find the horizontal asymptotes, I just look at n and n. I will compare now the power of p of x with the power or the degree of the q of x or the denominator n. Now, if n is less than n, so the graph now its horizontal asymptotes, it will be at y equals 0 or at the x-axis. So if m is less than n, it will be at the y equals 0. If m is greater than n, I will say that there's no horizontal asymptotes. But if m is equal to n, like x squared minus 3 over x 2x squared plus 4 as an example. I will look at the coefficients now, here and here. What is the coefficient of x squared? It is 1.
What?
Up.
Oh,
One,
Yeah, one.
And what is the coefficients of the denominator? It is 2.
two,
So the vertical, the horizontal asymptotes now, it will be at 1 over 2. I'll repeat how.
1 over 2.
We know that the function it was, I will write it as ax plus c over bx plus d. So the horizontal asymptotes here, it will be a over b, the coefficients of the numerator over the coefficients of the denominator. Let's see now these examples here. What is the horizontal asymptotes of the rational function? The first one, I will check m and n. Now, what is the power of the numerator here? It is
They are
1.
equal.
And the power of the denominator is 1. So they are
1.
equal. So what I have to do now, I will say that the horizontal.
it is 2 over 1, so
Which
it
is 2.
So it will be, what is the coefficients of the numerator? It is 2
2.
over the coefficients of the numerator, it is 1. So the horizontal asymptotes now is 2. Go now to the second one. What is the power of the m or the numerator?
Less than
1. So and
It's 1.
for m, it is less than n. When m is less than n, so
y equals 0.
we have a horizontal asymptotes.
No.
Yes, yes, yes. We
Yeah,
have.
y
the
equals 0.
x-axis, y equals 0.
So the horizontal asymptotes will be at y equal 0. Now, look at the third one now. What is the power of the numerator? It is 2. And what is the power of the denominator? It is 1. So, since now m is greater than 1, so there is no horizontal asymptotes. Now, I want you please to find now the vertical asymptotes for each. So in the first column, we found the horizontal asymptotes. Now, I want now to find the vertical asymptotes. As we said before, the vertical asymptotes. Look here now. Did we have a common zeros?
No.
No common zeros. So add the real zero of q of x. So the vertical asymptotes here at x equal 3. Let's do b now. Did we have a common zeros?
It can be simplified into x minus 2 and x minus 1. So x minus 2 is common between the numerator and the denominator. Thus, the only asymptote is at x equals 1.
One or negative?
No, it is no vertical asymptote. The point of this continuity will be minus 2. I mean 1.
No, not here now. Here now we have x minus 2 over x minus 3 times x plus 1. There's no common factor, no common zeros.
I factor it wrongly. I'm sorry.
So I will say that when x equal positive 3 and negative 1. So we have here now two vertical asymptotes at x equal 3 and at x equals negative 1. Now let's do C now. In C here, did we have a common zeros?
No.
No common zeros. So what about the vertical asymptotes now?
It is 5 over 2.
Thank you. It will be at the real zero of the q of x. So it will be at x equal 5 over 2. This column is an extra.
Can you repeat here?
Here, what are the common zeros? Here, what are the zeros of the denominator? Plus 2x minus 5 equals 0. So 2x equals 5. So x now is 5 over 2.
Here, m is greater than n.
Yes.
So no vertical asymptote.
Why?
Because m is less than n.
If m is greater than n and we have non-common zeros, we will look at the zeros of the denominator. Now, let's go test 3. What is the horizontal asymptotes for the rational function? Let's start with A. Here, what is the horizontal asymptotes? Look at the degrees of m and n. If they are the same, yes. So I will look at the coefficients.
Negative 1 over x over 1. Negative 2 over 1.
Numerator of the coefficients of the denominator. So the answer now, so the horizontal asymptotes at at y equal negative 2. What about B now?
No horizontal asymptote.
Why? What about the power
It is
of m?
y equals 0.
What is the power of m here? It is 1. And the power of n, it is 2.
Oh, we're in B, yeah, I'm
Y
sorry.
equals 0.
So we say that at y equals 0 or at the x axis. The third one here, since now m
No asymptote.
is 2, it's greater than n, so there's no horizontal asymptotes. Now let's do the last problem in this lesson. Inshallah, we have 5 minutes. Or okay, I will take 5 minutes from the other period. Here now, problem number 4, graphing rational functions. How can we graph now the rational functions. The first step, you have to find the horizontal asymptotes. Then you have to find the vertical asymptotes. Then you have to find the x-intercept. Here are I wrote now the steps. The first steps, I have to write now the y-intercept. And the last step now, I have to plot or to look at the holes and then find an additional points to help me to get more information about my graph. So we find now extra points. Let's start with my function. My function is x squared plus x minus 12 over x squared minus 4. Look at how now to find the horizontal asymptotes. The horizontal asymptotes, what is the coefficients of, before that, I will ask myself, is the power of the numerator, is the degree of the numerator equal to the degree of the denominator? Yes.
Yes.
So because of that, I will say, what is the coefficients of the numerator? 1.
1.
So at y equal 1, we have now the horizontal asymptotes. Now it's about the vertical asymptotes.
It is at x equals 2 and x equals negative 2.
How can we solve it, Susan? Can you tell me how we solve it?
It is x equals 2 minus 4 equals 0. Bring minus 4 to the side and square and take the square root. So we end up with either negative 2 or 2.
So the first step, I will factorize the numerator. It will be x plus 4 times x minus 3. They are negative 12, add them plus 4, yes. Over x minus 2 over x plus 2. Did we have here a common zeros? No. So because of that, I will say that we have a vertical asymptotes at x equal 2 and x equal negative 2. So let's know that at y equal 1, 2, and negative 2. Let's draw it now on our graph. At x equal 2, at x equal negative 2, we have now our vertical asymptotes. At y equal 1, we have now our horizontal asymptotes. So I finished now the previous 2 steps. Now let's find now the x-intercept. How can we find now the x-intercept?
Make y equal to 0.
Thank you.
It is the y-intercept.
I will want to find the x-intercept. X-intercept, it's mean y equal to 0. When y equals 0, I will put this one 0 equal x minus 4 times x plus 3. Plus 4 minus 3 over x minus 2 times x plus 2. So when y is 0, when the numerator is 0. So at point, so x plus 4 times x minus 3 equal to 0. So at point negative 4 and at point 3 by finding the zeros of each term. So the x-intercept, it will be negative 4, 0, and positive 3, 0. Let's now find the y-intercept.
Are you typing something?
What?
Are you typing something or no?
Yeah.
Because it's not showing to me.
The size now will is not appeared for you. It's not appearing for you.
Yeah, it's not appearing for me.
No, teacher, it's not.
What's up? Maybe because the 45 minutes are finished.
Yeah.
Now.
Now, yes.
Okay. Let's finish now. So when x equals 0, I have to find now the y-intercept. So I will substitute now with my function with zeros. So it will be zeros squared here plus 0 minus 12 over 0 minus 4. So negative 12 over negative 4 is what? Is a 3. So the y-intercept now is 0, 3. Now let's do now to my here now. Negative 4, 0. Where's negative 4, 0? Is here. I will now to put now the y-intercept. 3, 0. And 0, 3. Then after that, you have to put what I have now to look for the holes. Now I need now to find an additional points. This additional points to tell me, to help me how they help me how can I draw the graph, or to give me a sense to get this how the graph of the function will be. Try 0.4 as an example. No, please, I want to just substitute 0.4, okay? Just 0.4 here, put it like 4 plus 4, 8 times 1 over 2 times 6. Then I will have my answer. Then I will plot at number 4 when the points will be. Okay, just substitute because there's no time. Did you understand what I say? What number 4? Substitute in the function and find where the new points will be. After that, no, because today I have to start the other lesson, the fourth lesson. I spend it 2 times. So here, after that, after I plotting many points, where are the other ones? 3 zeros. What's this? 0, 3, 4, 0, and 3, 0. Ah, yes, here. So by drawing this one here, after zeros, did you plot these 3 points? Okay. After that, choose number 4 as an example. Go to the previous equation. Substitute 4 here. You have to say 4. Here 4, here 4, and here 4. Then 8 times 1 equal to 8 over 2 times 4, it will be 3 over 2. So at point 4, it will be 3 over 2. So the function will be here. By now, I will draw now the graphs after plotting a points. Here now, try point 1 as an example. 1 plus 4 is 5 times negative 2, it's negative 10 over negative 1 times 3, so it will be negative 3, 10 negative 10 over negative 3, I mean it's 3.3. So where's the 3.3? It will be here. So that means that the function, I'm sorry, I don't know how it will be, but how it will be like this, but be sure that here is our x-intercept. And for the last one here now, I will do the same, and it will be like this. Okay, just plot a point, substitute in the equation, then put the point here in the xy coordinate, and draw the graph. If you find anything not clear for this problem, feel you can to ask me at the WhatsApp. Okay, girls, please, I have to go now. I have grade 8.
Bye-bye.
Thank you. Bye-bye.